Okay, our next topic is how do we find the surface area of the equations of the parametric equations. Okay, of the parametric equations. So remember that what is the surface area? Again, this is we have discussed previously in our calculus 2 course. That is, for example, if we have this curve y equals to f of x, y equals to f of x, and it is defined on this interval a to b. This is our a to b. And what is the main question, main problem here? We want to rotate this area under the curve. We want to rotate this area. Okay, we want to rotate this area under the curve. Let's say about this x-axis, a surface will be generated. A surface will be generated like this one. Okay, a surface will be generated um, okay and what is the main question here? We want to find the surface area. We want to find the surface area of this whatever the surface generated by this. We want to find its surface area, and that is given by this formula, 2 pi y under the root 1 plus dy by dx square, and we integrate with this with respect to x, and the limits of integration are from a to b. So this we have already discussed previously in our chapter in this calculus 2, but now we are going to do this thing, the same thing. For example, if we are given two parametric equations, x equals to f of t and y equals to g of t, and t varies from alpha to beta. So what will be the changes in this formula? We are going to get the following formula, which is given by this: s equals to integration from alpha to beta 2 pi y, but under the root we will get this formula dx by dt square plus dy by dt square, and then we integrate this with respect to t. We integrate this thing with respect to t, but this can also be written in this form. So suppose that this whole thing, it is denoted by ds. This whole thing, it is denoted by ds. Okay, so this whole thing here, this thing, we can denote this thing by ds. That is, ds equals under the root dx by dt square plus dy by dt square, and outside here we have dt. This can also be written in this form: ds square plus ds square equals dx square plus dy square. But so this formula s can also be written simply in this form: alpha to beta 2 pi y, and here you can write ds, as it is written here in this formula, 2 pi y ds, or it can also be written as 2 pi x ds. Okay, so let's do an example. Let's do an example. Show that the surface area of the sphere, it is 2 pi r square. Show that the surface area of a sphere, it is 2 pi r square. What is a sphere? Sphere, it is a foot. Sphere, it is kind of a football. Okay. What is a sphere? The sphere is a football, and we want to find its surface area. Okay. So this is our sphere, and in Arabic it is called, we call this kuratul qadam. Okay. So we want to find its surface area. But remember from our previous knowledge, this sphere is generated by the sphere. It is generated by a semicircle, or you can say half circle, semicircle. Think about this. Okay, think about this. We have a semicircle or a circle. Okay, so here we have a circle. Its center is 0 0, and the radius, it is denoted by r. And what are the parametric equations of this? The parametric equations of this circle are equal to x equals to r cosine of theta, and y equals to r sine of theta, but the next thing we need to do is to find their derivative. So remember again, as I have said previously, r is fixed, mean the radius is fixed, only the variable or the parameter is the theta. So dx by d theta, it is equal to minus r sine of theta, and dy by theta, it is equal to r cosine of theta. Here you can write theta. Okay. Here you can write theta, or you can also write d, no problem. But the next thing we need to find is that ds. Okay, we want to find ds. What is the ds? So remember, ds, it is equal to under the root. Here you can write dx by d theta square plus dy by d theta square, and outside here we have d theta. So substitute these derivatives here in this formula. We get minus r sine of theta square plus r cosine of theta square, and then d theta. So when after simplifying this thing, you will get the following. You can write this r square outside, inside it becomes sine square theta plus cosine square theta. So this is again a trigonometric identity, and its value is equal to 1, and then when you substitute here, it becomes r square multiplied with 1 d theta, and after simplification you will get r d theta. Now we are going to find our surface. We will find the surface area. So what is the formula for finding the surface area? The formula for finding the surface area is the following, that is 2 pi y ds. Okay, alpha to beta 2 pi y ds. So remember what is we only consider here the semicircle. Okay, x equals to r cosine theta, y equals to r sine theta. So here in this case the theta varies from 0 to 0 to pi. Why? Because we only consider the semicircle. We only consider the semicircle, or you can say the half circle. So then it becomes 0 to pi. This 2 pi you can write outside. And what is y? Y, the value of y is r sine of theta. Y equals to r sine of theta, r sine of theta. And what is ds? Ds is this quantity r d theta. So you can take out r square, because r is a constant. You can write this outside the integration from 0 to pi sine of theta d theta. And now let us integrate this thing, 2 pi r square. What is the integration of sine? The integration of sine, it is minus cosine of theta from 0 to 2 pi. And now we substitute these limits inside this cosine. So then we get the following: minus cosine of pi, and then minus cosine of 0, 2 pi r square. What is the value of cosine pi? Cosine pi, it is equal to -1. And what is cosine 0? Cosine 0, it is 1. This minus minus become plus 1. Then it will become 2 pi r square. So inside this minus minus again become plus 1 plus 1, and 1 plus 1, it is equal to 2, and 2 multiplied outside with this 2, and then it will give us 4 pi r square. 4 pi r square. So this is the surface area of a sphere. This is the surface area of the sphere. That's how you can do this thing.